Hello and welcome to another lesson on sets and set theory. So in this topic we'll be discussing sets. We'll look at what's a set, what are elements in a set, and we will also look at features of a set, and lastly we are going to look at set operations. So let's start by defining what a set is. So a set is a collection of elements. A set is a collection of elements. A set is a collection of elements which are precisely defined. So that's what a set is. It is a set of elements which are precisely defined. We can have an example of a family. So a family will have members, and each member will be precisely defined in that each member will have a name, they will have a gender, as in you can easily identify each member of the family. Another one we can have is a fraternity. So those are two good examples you can give of sets, a family and a fraternity. So now, what are some of the properties of sets? What are some of the properties of sets? Number one, the first property we can say is that the elements of a set are well defined. Number one, the elements of a set are well defined. Number two, the elements of a set are unique and there are no repetitions. The elements of a set are unique and there are no repetitions. Number three, we can say the second last one is that a capital letter represents a set and a small letter represents an element. While a small letter represents an element. So we can have an example of set A, e.g. you can say set A which has elements A, B and C, plus set B which has elements A, D and E. If we add these two, we'll get, say, set C with elements A, B, C, D, E. Take A, B, C, D and E. A, B, C, D and E. A, B, C, D and E. Remember we said that there are no repetitions in cells, yeah? So we cannot say A. So you just take C with elements A, B, C, and D and E. So lastly, the order, the last one we can say is that the order in which the elements appear is not relevant. Number 4, we can say the order in which the elements appear is not relevant. The order in which the elements appear is not relevant. So let's look at another topic, which is types of sets. Types of sets. So the first type of set we're going to look at is called a null set. A null set. And this is a set with no elements. This is a set. This is a set with no elements. So for instance, we can have e.g. set A, which has A, B, and C, minus set B, which has B, A, and C. If we minus these two, we get set C, which is a null element. So that's what a null element is, a null set is, which is a set with no elements. Number 2, we have a finite set. We have a finite set, and this is a set whose elements can be listed down in full. This is a set whose elements can be listed down in full. So with e.g. we have alphabetical letters. We can have an example. E.g. we have alphabetical letters, we can have vowels, we can have prime numbers, and just to mention a few. Those are just a few. Next we have infinite set. Number 3, we have infinite an infinite set. And an infinite set is a set whose elements cannot be listed down in full. This is a set whose elements cannot be listed down in full. For instance, we have odd numbers, even numbers, prime numbers can actually be listed down, cannot be listed down in full. So maybe this one is not correct. Maybe we can replace this with say days of the week. Sorry for that. Days of the week. Prime numbers cannot be listed down in full. Or months of the year. Months of the year. So those are just examples of finite sets. So Here on the other hand, this cannot be listed down in full. For instance, we have prime numbers, odd numbers, and we have even numbers. So those are some of the examples we can give of finite, infinite sets. Next we have universal sets. Universal set. A universal set is a set where all elements is a set of all elements being considered. Basically, this is a set of all elements being considered. Of all elements being considered. So we can have set A with, okay, this universal set is usually denoted by or those two symbols. So A, we can have a set A which has A, B, C and D, and we can have a set B which has C, D, E, F, C, D, E, F. So the universal set where all the elements are being considered will be given by A, B, C, D, E, F. A, B, C, D, E, F. So this now, the universal set encompasses all the elements being considered. The next type of set is called a subset. So we can have number 5, subset. It is denoted by C. So this is a portion of a main set. This is a portion of a main set. This is a portion of a main set. And it is usually given by, we can have an example, A, which has elements A, B, C, D, E, which has elements A, B, C, D, and E. And we can have B, which has elements A, C, and D, A, C, and D. So we can easily say that, therefore, B is a subset of A. B is a subset of A. And next type of set we have is known as a power set. A power set. A power set, on the other hand, is a combination of all subset extractions from the main set. It is a combination of all. This is a combination of all possible subset extractions from a main set. From a main set. So we can give an example of A, which has elements A, B, and C. So, and a power set is usually denoted by S. It is usually denoted by S. So the power set of A, B, and C will be given by, we'll have A, we'll have a null set, we'll have B, we will have C, we will have AB, we will have AC, we will have CB, and we will have ABC. So those are all the possible combinations of set A, which has elements A, B, and C. Next we have an overlapping set, number 7. Overlapping we can have an overlapping set, and this is a set of all elements that are common to two main sets. This is a set of all elements that are common to two main sets that are common to two main sets. So we can have an example, e.g. we can have set A which has A, B, C, D, and we can have set B which has C, D, E, F. So you can see this is an overlap. These are overlapping sets because C is common in both A and B, and D is also common in both A and B. Next we have number 8, disjoint sets. And disjoint sets, these are sets with no common elements. These are sets with no common elements. These are sets with no common elements. So you can have set A which has A, B, and C, and we can have set B which has Q, R, S, and T. So those are disjoint sets because there are no common elements. Next we have number 9, complement sets. Complement sets. So complement sets, these are a set of elements which are not in a set being considered. So we can write and say a set of elements, complement set, you can say it's a set of elements which are not in a set being considered, which are not in a set being considered, and they are part of a universal set, They are part of a universal set. So we can have a universal set. We can have a universal set with elements A, B, C, D, E, and F. A, B, C, D, E, and F. And we can have A, which is A, B, C, D. A, B, C, D. So a complement. So A complement will have E and F. A complement will have E and F. And a complement means the elements are not in A. It means the elements A complement. This one means A complement. And it means that the elements are not in A. Sorry, the elements are not in A. Next we have an equivalent set, number 10. Number 10 we have equivalent set and equivalent set, and these are sets with the same number of elements. These are sets with the same number of elements. These are sets with the same number of elements. So we can have an example, e.g. A. You can have set A which has A, B, and C, and set B which has X, Y, Z. X, Y, and Z. So those are equivalent sets because they have the same number of elements. Next we have equal sets, number 11. So lastly, we have equal sets. The last type of set we have is equal sets. And equal sets, these are sets with the same elements. These are sets with the same elements. These are sets with the same elements. You can have set A which has A, B, and C, and set B which has B, A, and C. You can also say that equal sets are equivalent sets, and the vice versa also applies. So that marks the end of today's lesson, and in the next lesson we will be looking at the Venn diagram and also looking at some practical applications of set. Thank you, and see you in the next lesson.